Every day we're going to focus on a new figure, every day. But I want to introduce you to all the figures right now that we're going to study. And why, see I got a little family tree going on there. Why they're separated into three different families. Okay, why they're separated into this one versus this one versus this one. Okay, they're all quadrilaterals. That's at the top because this is the quadrilateral family. Okay, this is the quadrilateral family. Let me introduce you to the first family, and that's going to be our focus for the first couple days of this unit, and that's the parallelogram family. Okay. Parallelogram. Now, let me just how this works. This tree works. Anything the parallelogram has, anything below it also. So any property of a parallelogram, the figures below it also have. That's how this works. Okay. Whatever a parallelogram has, the figures below have. What's part of the parallelogram family? What do you think? Just by looking at the looks of the shapes, little rectangle. Yeah. Rosie the rectangle via rectangle. Who else is a part of this family? Rhombus, little Randy. Yeah. And then we got Susie. Yep. The square. And don't get all crazy and weird on me about, oh, the rectangle and rhombus, same family got together and all of a sudden the square happened. That's not how we roll here. All right, again, why is the square at the bottom? All right, it's basically the golden child. Maybe some of you can relate. I certainly can. All right. It's got every single property of parallelogram, rectangle, rhombus, the square has. Okay, so when we start talking about these figures, the square's got it too. That's why it's on the bottom. So before we leave this family, why are they all grouped together? Why are they all grouped together? Why aren't, why isn't this figure over here or this figure over here? Here's why. These are the only figures where both pairs of opposite sides are, what's that symbol for again? Parallel. All right? This is the only figures where both pair of opposite sides are parallel. It won't happen in these next pairs. All right? It won't happen in the next family. All right? Those are the only ones where opposite sides are parallel. All right, so there's the parallelogram family. Next family. Anybody know what those look like?
I don't know what's the bottom of the trapezoid.
They're both. It's the trapezoid family. Starting with Tony, just the plain trapezoid. This is the trapezoid family. And then there's the souped up version of that, which is Isaac, the isosceles trapezoid. It's got a few more properties than the trapezoid. It's a 2.0 version, if you want to think of it that way. All right, why are these together and not with the parallelograms? What do you think? Scott? Yeah, this only has one pair of parallel sides. Doesn't have both pair, just one pair. That's why they're grouped together. And then we have the lonesome figure on the end. The outcast, the black sheep of the quadrilateral family. Now maybe some of you can relate now. And that's good old Kyle, the kite. Yes, a kite is an actual figure. Why is it all by itself? They have no pair of parallel sides, correct? No sides parallel in a kite. No sides parallel. So there's the quadrilateral family we'll study over the course of this unit. Today, tomorrow, Friday, we're spending it all on parallelogram. None of the rest of the family, just the parallelogram. So let's start here. What's so great about the parallelogram? First, shorthand. Nobody wants to write parallelogram every single time, including myself. So here's my shorthand for parallelogram, everybody. Everyone remember that was the parallel symbol, two vertical lines. Parallelogram. That is how I will shorthand parallelogram, and you can feel free to do that yourself. All right, parallelogram. I'm going to call this parallelogram ABCD. Parallelogram ABCD. This is the first time this year we had to pay attention to this. With a triangle, did it really matter where I put if it was triangle ABC, where I put ABC? Absolutely not. But it matters now where I put ABCD. Go ahead, put A at any vertice. Go ahead, put A at any vertice, kids. Doesn't matter where you start. But here's the rule. You have to label it clockwise or counterclockwise. You cannot jump diagonally. So if it's A, B, C, D, I got to go A, B, C, D, or A, B, C, D. I can't put B opposite it. All right, so that's the rule for any quadrilateral, just not a parallelogram. You need to label any quadrilateral in a clockwise or counterclockwise direction. All good? Yep. We're all right? Okay, so let's get to the properties now. We got 5 of them. You guys already know one from the family tree. What's one property of a parallelogram? Opposite sides are? There you go. Opposite sides are parallel. You can use the parallel symbol if you want. I'll write it out. Opposite sides are parallel. So let's mark that on our diagram as well. What do you think? You'll probably be right. What do you think are some other properties? Probably going to be right if you guess. Calvin, what's up?
Opposite sides are congruent.
Opposite sides are equal too. Congruent. Perfect. Opposite sides are congruent. Yep. Not every side, just the opposite side. So here we go. Hash mark, 2 of them, 2 of them. Opposite sides are congruent. What? Any other properties? Probably be right. Romeo, what's up?
Opposite angles are congruent.
Yes, they are. Look at that. Opposite angles congruent. Just so I know you know what opposite angles are. Give me a pair of opposite angles that would be congruent in our diagram. BN, D, and then also AN, C. Correct. All right, we got 2 more. I don't expect you to get the last one. Maybe this next one, though. Maybe this next one. These are parallel, right? Anybody remember from our parallel line unit? Carter? Okay. The interior, same side interior supplementary, right? But I'm going to call these instead consecutive angles. So ready? A and B add up to 180. B and C add up to. Okay, so that's what I mean by consecutive. Consecutive angles are supplementary. You guys are doing a nice job on them. All right, I'm not expecting anybody to get the last one because it's not even on your diagram yet. Any questions on these 4 before I get to the last one, which is kind of a little bit unique to the other 4? All right, last property. What am I drawing in right now? What's this called from yesterday? Diagonal. And what's this called? A diagonal. So when I draw in both diagonals in a parallelogram, they bisect each other. They bisect each other. Let's get the property down and then talk about what the heck that means. Diagonals bisect each other. There's your 5th and final property. Diagonals bisect each other. All right, let's see if we're on here. So I'm going to call this intersection point E. What can you tell me now? If the diagonals bisect each other, what facts are now true up here? Diagonals bisect each other. What's true? Give me a true statement. Come on, you know what the word bisects means. Molly.
BC is
There you go. There's one. EC equals EA. They bisect each other. Each other they bisect. Lisa? EB and ED are equal. All four aren't, but those pairs are. How's that look? Question for you?
Oh, no, never mind.
Okay. I got one more challenge question. Give me a vocabulary term for point E then. Point E is the what of each diagonal? Congruent, congruent. Congruent, congruent. Point E is the, you're way overthinking it. This is the what of each line segment? Midpoint, isn't it, right? Midpoint. Cuts each side in half. Yeah, that's the midpoint. So where the diagonals intersect is the midpoint of each. All right, you ready? Let's do this. Ready for number one? Some of these are going to be, look, these are going to be very easy. I'm not trying to do them because it make you feel better. I'm doing it because I'm really concerned about the theorem used part. All right, how are we going to explain ourselves what we did? 10 and 2x minus 4, what do you know about them based on the properties? They are? Okay, 10 equals 2x minus 4. They're equal. I don't want to know what property you use, but you used a property to say they're equal. We're not guessing. 2x equals 14, x equals, okay, 7. I'm not that, great job. You can do some simple algebra, great. Now it's the theorem used. Hey, what we write here right now, this is going to go in the reasons column tomorrow when we start proofs. What property did we use? Diagonals bisect each other, but I'm not going to write that. I'm going to write a little more. Here's what I want tomorrow starting in your proofs. Parallelogram, you can use the abbreviation, parallelogram implies, now you can write the property. So because I had a parallelogram, that means, again, what property did we use, Emma? Diagonals bisect each other. So that's what I would expect here. Okay. Parallelogram implies diagonals bisect each other. And that's what's going to go in the reasons column tomorrow. Hey, 2's pretty darn easy. 2's very easy. I don't care. You're looking for the theorem, actually. So what's x? Okay, 16, done. Great job. That's what I'm concerned with now. Why is it 16? Parallelogram implies, and yep, we just go by the property we used. Opposite sides congruent. That's what's going to go in our reasons column if I need to use a property tomorrow. And finally, 3. What are we doing with 4x minus 10 and 3x minus 2? Set them equal, right? The side problems aren't hard at all. It's when we get to the angles in a second, when we need to find angles. That's when it's going to get a little tougher for us. X equals 8. And then theorem. There you go. Not too challenging at all. Now we will, though, when we get to the angles. Is there anything I can answer right now about properties or sides before we get a little more intense with the angles? All right, at least I'm not asking a theorem here for the next couple here. I'm not asking about a theorem. Okay, real quick in your group, go ahead, figure out the missing angles for 4. Quick in your group, about 30 seconds it'll take. Use your properties. Use your property. Got to use properties though. I don't need a theorem. None's listed. I don't need one. I don't need a theorem. I want you to apply a theorem, but I don't need it written. Okay, I'm good. Ready? Angle 1, what do you have? 40. Consecutive angles are supplementary, right? Consecutive angles are supplementary. That's a theorem. Angle 2, 140. Opposite angles are congruent. And then angle 3, 40, you could use either one. Consecutive angles are supplementary or opposite angles are congruent. We're all right. Okay, let's go to number 2 here. I'm going to let you go here in a second, but whoa, easy. Hey, everyone just stop for a second. I just got to show something. Okay, I get it. You could use angle 3. You could find angle 3 by doing 180 minus 45 minus 113, right? Because it's angles in a triangle. All right, watch this way, though. What do I know about opposite sides? They're congruent, and they're first thing we learned today. Why would I need that property? Well, anytime you have that with a diagonal drawn in, what type of angles do you see up here now? Between 22 and 3. Remember what we called those? Alternate interior. And they are always congruent. That's why I gave you parallel lines. So right now I could just say, oh, angle 3 is also 22 because it's alternate interior with angle 3. All good. Last thing I'll leave you with. It is okay to find an angle that is blank. You may need it to find an angle that's numbered. So you and your group right now, I'll give you not too much time, but go ahead on 5 and 6. Find all the missing angles on 5 and 6. You don't need a property either. Maybe just some vertical angles are congruent. Linear pairs, supplementary. Go ahead with your group. However you get the job done. Find a blank angle to get to a numbered angle.
Number four should.
No,
What? You know, this top one right over here.
Any angle that's giving you problems. Before I'm just going to list through the answers. Unless there's an angle that you want to go over how to get, you're stuck on any angles. Okay, let's see how we did, and then again, we'll ask questions at the end. Angle 1, 113. Angle 2, 45. Oh yeah, then this one, yeah, 45. Yep, gotcha. It's alternate interior. And then what else do I have? Angle, that was it. 1, 2, 3. Okay, on this one here, number, what was it, 6 for you guys? Yep. Angle 1, 61. Angle 2, 72. Angle 3, $1.08. And finally, angle 4, 32 degrees. Anything we want to ask now with this one? Again, you don't have to use a parallelogram property. Like, hey, finding angle 2, they were vertical. Done. Finding angle 3, they're linear pairs. I don't need a parallelogram property. And also, maybe finding an angle you don't need may lead you to an angle that is numbered. All right? Any questions before we leave it? All right, one more graphing question. And remember what we said about graphing tonight. It's not optional. You have graph paper in the back of your packets to use. All right, I believe it's 1 or 2 questions I'm going to ask you to graph tonight. It's not optional. So I'll give you guys a minute to graph or parallelogram WXYZ. All right, we have them graphed. Question, find the coordinates where the diagonals intersect. We can draw them in. Sure, we can draw in the diagonals. But I don't want you to use the graph to figure out where they intersect because you can have a decimal in your answer. And if you're not using a great straight edge and you're just freehanding it, probably not going to work either. So I don't want you just to use the diagram. I want somewhere algebraically to figure out where they intersect. What do you know about these diagonals? If it's a parallelogram, bisect each other. So we talked. If this piece is equal to this piece, what's this point on WY? The midpoint. And I can also do it for find the midpoint of ZX. It doesn't matter what midpoint you find, which diagonal. It's going to be the same. They share the same midpoint. So I'm either going to do the midpoint of WY or you can do the midpoint of ZX. It's going to be the same answer. Ooh, now everyone's waiting for me, huh? What's the midpoint formula?
Square root of 1 over 2 and y2 plus y1 over 2.
X1, add your x's and divide by 2.
Yeah.
Add your y's, divide by 2. I'll give you guys a minute to do that. And that'll be the intersection of the diagonals, the midpoints of them. Add your x's, divide by 2, add your y's. And hopefully the x coordinate is going to be 0. And this is why we don't look at the diagram. What's your y coordinate? 5 plus negative 2 divided by 2. Or 7 plus negative 4 divided by 2, 1.5. So that's for the intersection of the diagonals. Okay. Might be a good time. Online textbook. Grab a textbook. Let's get going. I'm not going to waste the minutes we have left. Graph means graph. It's in the back of your packet tonight. I'll be right over, Carter.